fill out the definitions, take notes, fill out observations and conclusions as we go along in this process, okay? Okay, so water is known as the universal solvent. Water is known as the universal solvent because it dissolves mostly any substance, right?
Right.
So even though it dissolves many things, there are also many things that water does not dissolve, which is what we're going to focus on today. We're going to talk about hydrophobic and hydrophilic substances. Can anybody tell me what the word hydrophobic means? Let's break it up into its root and its suffix, okay? Hydro means water. Exactly. And phobic means fear. Exactly. So that's exactly what a hydrophobic substance is. It is something that is afraid of water. So what do you do when you're afraid of something? Exactly. You're going to run and get as far away as you possibly can, right? You're not going to get near it. Well, in the same way, a hydrophobic substance is afraid of water. So it's going to run away from those water molecules. Okay. So the formal definition of a hydrophobic substance is something that has a low affinity for water. And all that means is, like we said, that the substance is going to repel those water molecules. And in doing so, the substance is going to form its own distinct layer so that you can actually distinguish it from water. So to better understand that, let's look at what's happening at the molecular level. So what you see happening is that these substances, the molecules, are going to cluster very close to each other in a tightly packed manner like this. And the water will also do the same thing. So these water molecules are going to be tightly packed like this. So as a result, you'll see different layers. And in this way, hydrophobic substances minimize their contact with the water because remember, hydrophobic means they're afraid of water, exactly. All right. So in contrast, let's talk about hydrophilic substances now. Hydro means again water. And philic, you might not know this word, but what's the opposite of fear? Love, exactly. So what do you do when you love something? You hug it, right? You want to cuddle with it. You want to be as close to it as you possibly can. Well, in the same way, a hydrophilic substance wants to associate with water. It wants to be with water. So the formal definition of a hydrophilic substance is having a strong affinity for water. And all that means is that it's going to dissolve in water very readily. And what that means is that you won't be seeing a distinction of layers like you would in a hydrophobic substance. So what's going on here is that the molecules are going to disperse and scatter around with the water molecules. So they're friends. They want to be close to each other, so they're going to interact.
Yes.
Okay? All right. So can anybody think of any examples of either a hydrophobic or hydrophilic? Nothing comes to mind? Okay, well let me give you an example. What about oil? You know, you've heard about oil spills in the news, and what they show on TV is, you know, a section of the ocean, and then you'll see this oil, literally, like an oil spill. And what do you see about the oil is that it's not sinking, it's just floating on top of the ocean, right? So if it's floating and it's not dissolving in water, what is oil an example of? Hydrophobic. Exactly! It's an example of a hydrophobic substance. Okay, so to better visualize this concept of hydrophobicity, let's do an experiment. But how are we on the key terms so far? Are we thumbs up, thumbs down?
Thumbs up.
Any questions so far?
No.
Awesome. All right, so let's do our experiment. So in your own stations, I want you to follow along. Do your experiments as I do it with you guys. And the first thing I want you to do is I want you to pour some water into your beaker. Okay. All right. Now, I want you to take take your spoon and take some of the magic sand and pour it into your beaker. Okay? And now, go ahead and take your straw and mix and stir very, very, very well. Okay? All right, mix. You can shake it. All right. Now, take a look at it. And what can you tell me? What do you see is happening? What's going on? What was that?
Floating.
Yeah, there's actually some sand that's floating, but there's actually a layer that's just sinking, right? It's at the bottom.
Yeah.
So it's not dissolving, right? No. It's not dissolving. But before we make our conclusions, let's look further. So take your spoons and scoop out the bottom layer that you see and put it in your hand. And what can you tell me about the sand?
It feels dry.
It's completely dry, right? But how? If it was just completely immersed in water and it's completely dry? Well, from observing that it forms its own layer and noticing that it's still completely dry, what can we conclude about magic sand?
It's hydrophobic.
It's hydrophobic, exactly. Okay, all right. And then you also see a layer that's floating, right?
Yeah.
This layer that's floating is actually due to the surface tension, which is what we're going to talk about tomorrow, okay? But just keep that in mind. All right. And we talked about how in oil, you'll see that the oil layer floats, right?
Yes.
But in this case, it's sinking.
Yeah.
So what determines whether a hydrophobic layer is going to float or it's going to sink? You might not know this because we haven't covered it yet, but it's actually density. And density, all it is it's the substance mass over its volume, okay? And when something is less dense than water, it's going to float. If something is more dense than water, it's going to sink. So here in our magic sand, the majority of our sand is sinking. So what can we conclude about its density? Is it more dense or is it less dense than water?
More.
It's more dense than water, exactly. All right. And then the oil, when we said that oil floats in water, oil is then more or less dense than water?
More.
Yes.
Less dense because it's floating. Remember, if it's less dense, it'll float. Okay? All right. So, any questions?
No.
Okay. But let me tell you the secret to magic sand then. What makes it magic? It's not really magic. It's regular sand, but the only thing that is special about it is that it's coated with a substance called trimethyl hydroxysilane. Can everybody say it with me? Trimethyl hydroxysilane.
Silane.
Excellent. And all it is, you don't need to memorize this formula, but it is a component composed of 3 methyl groups, a silicon, and a hydroxy group. That's all it is. And so from this experiment, we can conclude that trimethyl hydroxysilane again is
Hydrophobic.
hydrophobic. Exactly. All right, guys. So now I want you to continue working in your stations and finish your lab work, your lab questions. If you have any questions, please raise your hand, and I will be walking
Yes.
around. Okay?
No.
All right. Can I get a thumbs up, thumbs down? How are we on